Hey everybody, this is Roger Terrell. I'm going to give you a brief review on strong acids and strong bases. So, let's just get right to it here. What is a strong acid or a strong base? Strong acid means that the number of moles of acid that you put in is equal to the number of moles of H plus in the solution. Right? So, basically, that's just to distinguish it from a weak acid, where you can put weak acid in and it'll only partly dissociate, and then you'll only see some of the acid. So, for example, you could have an acid like HCl, which is a strong acid. And it's strong because if you put, let's say, N equals 0.1 moles of HCl into 1 liter of water, then you would have HCl. It's actually a gas, the way that it starts, right? And you can add it to the water, and you will get H plus ion concentration equal to 0.1 moles divided by 1 liter will equal 0.1 molar. Oops, actually, I don't think I need it there. 0.1 molar, right? The same is true of the chloride ion, right? The Cl minus will equal 0.1 molar as well, right? And so just a short list of strong acids and bases. We had HCl, Br, Hi, HClO4, right, perchloric acid, a little less common, but still out there. You've got HNO3, nitric acid, H2SO4. The first proton is strong. And let's see. And there's probably others. There's others. Right? So let's do a couple quick calculations using strong acids, right? Example of a strong acid calculation, you could say, well, if I have 0.1 milliliters of concentrated HCl, and I dissolve that in 10 milliliters of water, and by that I mean specifically that you're going to take these 10 mils and you're going to dilute them to a total volume or you're going to take this 0.1 mils and add enough water such that the total solution volume is 10 mils. So you add water until it's 10 mils. So it's not that important for dilute solutions, but as you have more concentrated solutions, sometimes the volumes don't quite add up. So dissolve in water, and then to volume, equal to 10 mils. Right? Then what we have as well, what is the HCl concentration? What is the H plus ion concentration? And what is the pH? Those are a few strong acid questions we could ask. So first of all, we know that all these things, right, the HCl concentration and the H plus, they're going to be proportional to the amount of concentrated HCl, right? So, so we know that this 0.1 mLs, that's going to be like a starting point for us, right? And we're going to multiply and divide things into that such that we come up with an amount of H plus, right? And this is, we're going to call this HCl concentrated solution, right? Now, concentrated HCl is, it's sort of a standardized material, right? It's not exactly, but it's close, because it's between 35 and 37%. That is weight in HCl, right? So, and all this means, what this funny expression means is that for every 100 grams of concentrated HCl, there are 35, say, grams of HCl, of the component HCl, right, as opposed to the solution, right? So let's go ahead and do this calculation. So we have 0.1 mLs concentrated HCl. Now we have to do a transformation that gets us from mLs of concentrated HCl to grams of HCl, right? So what we're going to use is the density, right? And that's going to be 1.2 grams of HCl per 1.0 milliliters of HCl solution, right? And this is grams of the concentrated solution per mil of the concentrated solution. And then from there, we're going to multiply this guy by the next factor, which is going to be the 35%. And that's going to be 35 grams of HCl for 100 grams of HCl solution. Right. Now, at this point, let's cancel units, right? We've got mils of concentrated HCl. They cancel. Grams of HCl solution. That cancels. Now we're down to grams of HCl, right? Multiply by 1.2. Multiply again by 0.35. Now, grams of HCl is good. Now we're going to change that to moles. Let's say 1 mole of HCl for how many grams? Well, Cl is 35.5 grams, and H is 1.0 grams. So it's going to be 36.5 grams of HCl, right? So this unit grams of HCl can cancel down here. Now we have moles of HCl in this 0.1 milliliters, right? Now the last step is to divide by the total volume that we're going to use, things, right? And that's 10 mils, right? Right. So now at this point we're going to have moles per milliliter. To get to the unit of molar, we need to change that to moles per liter. And so we're going to say that there are 1,000 milliliters per liter. Right? And we can multiply all this out, and I haven't done it yet, so hold on just a sec. Okay, so here we are with our calculator, and we can say 0.1 and then times 1.2, right? We don't need to divide by 1, right? Times 35 divided by 100, and then divided by 36.5 divided by 10 and times 1,000. And it gives us 0.115, right? 0.115. Oops, that's not the right pen. 0.115 moles of HCl per liter, right? So this is known as the formal concentration. Of HCl, right? That's just to say this is the number of moles that we added divided by the number of liters of solution formed, and irrespective of what may have transpired after that, right? Irrespective of the extent of ionization, right? Right? So now, the easy part is that since HCl is strong, then we know that the formal concentration, right, is equal to the H plus ion concentration right? So that is 0.115, right? And that's molar. And probably we should subscript the 5 here since we don't know it for sure. We're operating at basically 2 sig figs, so we could say 0.115 molar. Right? Now, lastly but not leastly, we can calculate the pH here. The pH is equal to the negative log of the H plus ion concentration, which equals, let's see if we can do a log with this stupid calculator. The log of that. Now we're going to change the sign. Oops, I don't know what I just did there. Go back. Okay, so just the log of that, right? So the log of that times -1 is equal to 0.939. 0.939, right? Okie dokie, so it's approximately pH of 1.0, right? Alrighty, so that is all I've got for you on strong acids and bases for now. More on general equilibrium soon.